Hi there, friends, and welcome to an update on the volcanic situation going on in Iceland for today, April 30th. It is about 10:30 a.m. Mountain Daylight Time. That would be about 4:30 p.m. over in Iceland. Thanks for joining me. I'm Geology Professor Shawn Willsey, and today we're going to look at just a quick run through some of the data. There's some interesting trends in what's been happening in this eruption that began on March 16th. So we'll run through some of the data, look at some of the news that's come in. As always, thanks to Amanda Joe over in Iceland, who sends me some of the news updates and helps me compile these little volcano updates for you every so often. So thanks again for joining me. Appreciate your support and your time today. So let's go ahead and get right to it. We can see the webcam here shows our same cute little spatter cone that's been erupting more or less continuously since its eruption began March 16th. This has become the primary site of eruptive activity, both at the summit crater, where it continues to slowly build up the crater walls with occasional ejections of lava spatter that accumulate along the rim. And then also, a little hard to see here during the daytime, but there is a conduit from the base of the spatter cone that carries lava out into a perched channel that flows off to the south very slowly, and it doesn't extend too far from this area, but then some of that lava actually extends further to the south, just beneath the crusted over surface. And so that's largely unchanged since we've been looking at the last few weeks of activity there. But what I really want to focus on today is some interesting trends in the GPS data and just kind of where we're at right now. So if we come in here to the GPS data and look at the 8-hour run for Svartsengi. So this GPS station is most centrally located over the magma body, the storage zone that's supplying the shallow storage zone that's supplying magma to the surface. We think there's a lower source of magma that's feeding this from depth, and some of that magma is being stored beneath the Svartsengi power plant area in a shallow storage zone about 5 kilometers deep. And from there, some of that magma is making its way to the surface via the spatter cone that we looked at. So interesting trend here in that this is what we've been looking at over the past few weeks. So here's the March 16th eruption. So the inflation that caused the ground to rise as more magma was accumulating in the subsurface, that all dropped when the March 16th eruption began. So some of that magma left the system, erupted at the surface. That caused the ground to drop about maybe 10 centimeters or so. And since then, we can see the trend. It was initially just barely uplifting a little bit, but since about early April, you can see a little elbow here, a distinct change in slope in the data. And so the inflation rate of the ground has been much more steady in terms of uplift, presumably as more magma has been invading this area. And this has been the real conundrum we've faced, is looking at this data and trying to reconcile how this system is simultaneously transporting magma to the surface through the spatter cone, but then also storing a larger quantity of magma in the subsurface and causing the inflation that we're seeing here. One of the many models I kind of just threw out spitballing ideas was a constriction in the system, and a lot of people tended to like that idea or that model, that there's a constriction that only allows so much of this excess magma to make its way to the surface through the spatter cone, and thereby the constriction is holding back a larger portion of the magma, and because it's causing inflation in the system, we may be seeing the system pressurizing. So if you look at the last bit of data here, which I think is the most revealing and interesting, so we can see the upward trend, ebbs and flows a little bit, but pretty steady. But the last few days or so, overall, it tends to be flattening out a bit here. And so that possibly may indicate, as an interpretation, that the magma has occupied as much of the space in the subsurface as it can. This is just one possible interpretation. And that now the system is pressurizing. So now as more magma comes up into that shallow storage zone, it doesn't have anywhere else to go. There's no further uplift, or very slow uplift, in response to that magma influx. And so now we're just seeing the system pressurize. And we really could be headed towards the next event. Now, when that occurs is anyone's guess. Exactly what that looks like is open to several different scenarios as well. But that's the data we're seeing here. And we can see that on other stations as well. If we come over to the Blue Lagoon site, this one, interestingly enough, shows almost a bit of deflation. Let me get over to it here. Again, just 3 data points, not a verifiable trend, but there's the inflation. And that reached a peak here, basically 24 or so hours ago. And then you can see a drop and then a little bit of an upward trend there, but a little bit of a drop there. And so potentially what we're seeing, looking at all these different stations in aggregate, is we're seeing the inflation rate, the uplift rate, at least stabilizing, if not completely stopping, at least it's slowing down considerably. Here's the Eldvorp station here. And so you can see that with the various stations there. So you can go into the GPS site and check that out as best as I can. But a definite change in the behavior that we've been seeing. The steady inflation rate that we've been seeing for several weeks now seems to be leveling off, and the ground is not rising much higher, if at all, over where it was just a few days ago. And where this takes us exactly, again, is anyone's guess. Now, what we might expect to see if inflation stops, but the system is getting pressurized, we might see in the coming days is an uptick somewhere in the system in terms of earthquake activity. So as the system gets pressurized and that pressure exerts stress on the surrounding rocks, we might see those rocks breaking and small earthquakes. So these will be very small earthquakes. This is our last 24 hours here, looking at all the quakes. You can see there's just not a lot. I mean, there's, a dozen or so quakes along the trend. They're all pretty small, generally 1s or smaller in magnitude. In terms of depth, they're kind of what you'd expect from this system, in sort of that 5 kilometers or a little bit more shallow, their depth. Some of these ones down by Grindavik might be more of a stress reactivation of some of those Graben bounding faults that we developed earlier a few months ago in this eruption sequence. So not a lot there. If we look at the last week or so of earthquake data, again, just not a whole lot to really sink your teeth into. So you can see the trend there. Most of these here are right around the vent and the eruption site, but again, very small earthquakes over the past week. And these are, of course, color coded. So the more recent ones are in red, and the more the older ones go to yellows, to greens, to blues when they're about a week or so old. So no noticeable, at least what I'm seeing here, uptick in earthquake activity yet, but we know, as we've seen from past eruption events here, that this can escalate quickly. So within a few hours, we might be seeing a definitive or definite uptick in seismic activity. But for now, things seem to be more or less status quo as they have been. And getting to the latest Met Office update, so let me walk you through this a little bit. This was from today, so this is the most recent Met Office update. So the land rise of the inflation still compared to Svartsengi, but there are indications it's slowed down. So just going through that GPS data like we just did, that it looks like the inflation, it has slowed down. Pressure is building in the magma chamber. Total volume of magma is estimated to be about 10 million cubic meters. Despite land subsidence, model calculations show that magma accumulation under Svartsengi continues at a similar rate as before, indicates that pressure is increasing in the magma chamber. So the question, of course, now is, well, how much pressure can accumulate in that magma storage zone before that triggers some change in the eruptive activity that's already ongoing, or before that causes maybe magma migration into some new area, which would, of course, be accompanied by elevated seismicity. So last 2 weeks, the overall flow of lava from the crater, which is still erupting, is about a third of the average flow in the first half of the month. So it's slowed down over time. There's still considerable uncertainty about the future, but it's likely this will soon lead to news, and the power of the eruption on the Sunuks crater series could increase. These are all Google translated. They don't have the English version out, so a little bit of language there. Risk assessment will be updated. What else do we have here? Yeah, Saturday on my last update, there was a small little lava tongue that crossed one of the protective berms the walls there near Grindavik, but it was not a big news event. It was just a small little lobe there. The flows at that south end of the flow field are they're moving very slowly. It's more or less stagnated there, but there's still inflation and there's still magma that's still molten in the subsurface there. Then they give us some numbers here in terms of the size of the flow field. It's about a little over 6 square kilometers. The volume and thickness of the bed, though, continues to increase. So the volume of this flow that began on March 16th is about 34 million cubic meters of material, and the average thickness is around 5.5 meters. So it's a very thick lava flow area because, again, that crust, that top area of the lava flow crusts over, it stays molten beneath, and so it can actually inflate. If it's running into a barrier and it can't flow laterally, as that crust is somewhat flexible, and so it'll allow that magma to rise and inflate, and that can actually build up the thickness over time. Let me take you to the map here. So they've got a map, and this shows the flow field for the March 16th eruption in yellow and orange and red. The older flows from prior eruptions are in different shades of purple and pink. But the main thing they're showing here, let me zoom in a bit on that, is you can see it changing there a little bit. These were from April 15th to April 25th, so a 10-day difference in the thickness of the flow field. And where you see that most notably is down here along the berm. You can see it going from more of a yellow color to a little bit of an orange color. So that indicates thickening of the lava flow there. So a little bit over here to the east of the quarry, which is here. And then right along that defensive berm, there's some thickening. And then, of course, near the cone itself, there's some thickening of the lava as well. So you can see that this whole flow field has inflated a little bit, but most specifically at this leading edge here, as there's been some inflation and a few little minor breakouts of lava. But the lava is fairly slow moving here. The eruption output is somewhat slow, and so that somewhat controls how much lava and how quickly that lava can move down at this leading edge here. So continuing on with the Met Office update, let's see what else they have. Inflation measures up. Let's see, land rise still measures up to Svartsengi, but their indication it slowed down the last few days. So that's the inflation. The inflation of the ground, the uplift, has slowed down a little bit. We saw that with the GPS. At the same time, eruptive turbulence has shown a slight increase. So they're seeing a little bit of an increase in just the eruptive output from the spatter cone. And microseismic activity has temporarily increased in the Sunux crater series. So I didn't really see that just looking at the earthquake data, just eyeballing it. But they're the ones looking at it with more scrutiny. So we'll take that at their word. That sounds accurate. Although there are indications that the inflation is slowing down, model calculations show the magma accumulation continues at a similar rate. And so then we get down to, okay, measurements and model calculations indicate there's considerable uncertainty about the future, but it's likely that it will soon make headlines. So something's going to happen soon. This is not a sustainable situation looking forward. If magma accumulation continues, it's more likely that the power of the eruption will increase significantly rather than it will subside. Based on the latest measurements, however, it's difficult to say which of the scenarios below is most likely. So we'll either get new fissures opening up. So if the pressure in the magma system is too great than what can be accommodated by the existing plumbing system or conduit to that spatter cone, then that's going to necessitate new fissures and new vents opening up. We expect those in the same general area as the existing spatter cone and this prior eruption in terms of where those fissures opened up. Or it's possible that we'll just see an increase through this existing spatter cone until there's some balance reached between the inflow and the output. So those are the two scenarios that seem to be the most likely at this point in time. And then we have the graph we've looked at in the past. This is us here in red. Days since the beginning of this eruption. We're well over 40 days now, almost 45 days. And where exactly this goes, and this, of course, here on the y-axis is the volume of magma that's modeled to exist in the subsurface, a little bit over 10 million cubic meters. So how high will this trend go? How much volume, what will the volume of magma be that's intruded before this thing results in either magma intruding in the subsurface and moving and breaking rock and forming some new space underground, or will it break through to the surface either at the existing spatter cone or some other location to create an increase in eruptive activity? And those are the questions no one has a firm answer to right now, but it's fun to watch. So a couple news stories. This one was very confusing to me, and maybe it's somewhat of the Google Translate, but offering sort of opposite opinions a little bit. On one hand, we have the geophysicist says there's nothing dramatic to report about the volcanic eruptions, and then we have Professor Thordarson, who says there's signs the activities increased during last night, and so kind of just two different perspectives there. The geophysicist, the flow is very small. We're not starting to see an increase. There's been a slight increase in turbulence, but there's nothing dramatic that's happening, and there's no certainty there will be any increase in this eruption, even then if there will be one. So I'll put links to all these news stories under the video description if you want to read these through on your own. And so kind of an interesting perspective there. Another story here. Inflation may have stopped it, but the eruption appears to be intensifying. So again, Professor Thordarson quoted in this news story. It seems to have added a little to the soda tonight. That just means, I think, in terms of gas emissions and eruptive activity, the lower storage chamber is full, and then the amount of magma that was flowing into it just goes straight up. He says that the magma flow from the deeper storage chamber has so far been divided approximately in half between the shallower magma chamber and the eruption, and therefore the flow now increases from 3 cubic meters per second to 5 or 6 cubic meters per second. Again, I'm not sure exactly, how that information is known exactly, but interesting perspective. So there's another story for you. This one here, kind of a similar one, but this one, let's see, what was on this one that I found interesting? This just has a different expert from the Met Office, Benedict Olfigsen. The landmass has slowed down. Seismic activity has increased slightly, which could indicate that magma from the magma chamber under Svartstengi is starting, or I would assume that means starting to move. He says it's uncertain how the magma will come to the surface. Either the flow of lava from the currently erupting crater can increase, or a new fissure will open. And then finally here, what's interesting here, looking at here's the defensive berm here, but this lava flow around the perimeter of parts of this thing has inflated to the point where it's actually a little bit higher than the berm. So there, it's actually building the wall up a little bit. So let's see, what did I find here? Yeah, I think that was kind of the main thing there, is that they're continuing to modify the berms. They're doing what they can to continue to prevent lava from flowing into the town, but it's a constantly dynamic and changing process. When we began, there was nothing on the outside of this thing, and then the lava flowed up against it and along it to the southeast, and now as this perched lava channel south of the spatter cone has sort of been building up and inflating, it's actually risen to the point where in some places it's as high or even higher than the defensive berm itself. So it'll be interesting. I mean, if a new fissure opens up, that could be in some ways a good thing, because a new fissure opening will erupt lava from a new area. And so, if we had, let's say, a fissure opening up over here, that's going to be pouring that lava out onto this landscape here, and that's probably going to fill in a lot of this available region for that lava to go. I guess possibly, I'm just thinking this through on the fly, but if we increase the activity at the existing spatter cone and feed this current flow field that goes to the south, which partially is a subsurface tube system, that's maybe not such a good outcome, because then it's already up against that defensive wall and it could start flowing over the top of it or continue its march down to the sea if we increase the output. So then again, there's no guarantees if the new fissure opens up where it's going to open up. We would expect it to open somewhere between Hagafelt and Stora Stogafelt, these two hills here, because that's where we've seen the bulk of the other fissures in the past open up. So we saw the one from February. the one from December. Of course, the January ones were further south. They were down here. And so we wouldn't want to see one that far south, but it's anyone's guess exactly where that new event might open up if that actually were to take place. So just a quick update for today. Just wanted to get some of this new information out to you. I found especially interesting was the GPS data and this recent trend over the last day or two of essentially no inflation or very little inflation, and what that might mean. We've offered a few perspectives here. I'll be sure to link those video descriptions so you can read through that, and then we're just going to watch together. We're going to watch and learn together and see how this eruption progresses. The good news is Iceland has taken all the precautions. People are out of harm's way. There is some potential threat to some infrastructure, but it's fairly minimal. And I think they position themselves as best they can if this thing actually erupts again, depending on exactly how it goes. But also probably worth noting that Iceland is fully open, that this eruption and these ongoing eruptions here on the Reykjanes have not impacted 99% of the country and most of the tourism and the sites you would go see. I'll be leaving for Iceland here in about 2 weeks, and I'll be over there for about 2.5 weeks. So this does not at all deter my travel plans at all. And so if you have plans to go to Iceland or you have friends that are thinking of going there, make sure you educate them that this is a small event, that this is non-explosive, that it is non-hazardous to people visiting the island, so they can continue to gain the economic benefits of tourism. So with that, I'll sign off and have a great April 30th, and we'll see you next time. Take care.